Hello. Today I'm talking about significant figures practice problems. And it discusses significant figures down here. It gives you a little bit of idea of why we use them. And then there are several different problems here, but we're going to need some information on this second page because there's two things we're doing. In the first section here, we're just counting up how many significant figures are in each number. And there's certain rules we're going to follow. And then down at the bottom, we're going to start to do calculations using significant figures. On this side, addition and subtraction, and on this side, multiplication and division. And they also have their own set of rules in the yellow here. So let's get started. And when we're counting up sig figs, we want to follow the different rules. And there's all kinds of help on YouTube or just online finding these charts. So to quickly go through them, if we have a number here that has a decimal, but it's filled with numbers, we count each number, 1, 2, 3, 4, 5. So there's 5 significant digits. Second rule here is talking about zeros in between numbers, but you don't see any decimals there, right? Okay, so these are just whole numbers. So we got zeros in between these numbers all count as significant. So 1, 2, 3, 4, 5. That means there's 5 significant figures. If you have a decimal and there are zeros preceding the numbers here, those zeros are not significant. So you see that there's only 2 sig figs here, and that's these two, the 4 and the 5. Those are the only 2 significant figures. These ones are considered placeholders. The next rule there, if I have like 45 decimal 00, well, these zeros are giving some specific meaning to that number. So they do count as significant, but only if they're after the decimal. Okay, so 1, 2, 3, 4, all of those are significant. The opposite, though, is here. This number looks similar, but there's no decimal, right? So the decimal would be over here. These trailing zeros are not significant. So this is very confusing, right? We have the decimal here, and the trailing ones do count, but then we have no decimal, and the trailing ones don't count. So the only significant, there's 2 of them. The only significant is the 2 and the 3. And then this next one, we're not, that isn't going to apply to us, but you can always take a look at that. So that was very quick. You should take some more time in going over these rules with examples, but these are the practice problems. So I'm going to do a couple of them for you. And I'm actually going to start with number 2 here, because this can be a tricky one. Remember, with the decimal, which we saw here, these preceding zeros don't count as significant. But what about this 0 at the end? Is that one significant? Let's see. Well, the only thing that gives us an idea is probably this rule, number 4. And that final 0, that one is significant. So we have 1, 2, 3 sig figs. These are your sig figs right there. Okay. Now on number 3, we saw this example as rule number 5. There's no decimal here, so these zeros are non-specific, meaning we only have 2 significant figures, the 1 and the 2. All right? So go through these 10 using these rules and see if you can get each one of these properly labeled with how many sig figs or significant figures there are. Now down here, we're going to do a couple of examples. So when we do addition and subtraction, we're going to be rounding based on the decimal place. So whichever number has the smaller or least amount of decimal places, that's what we round to. So you see they got a number here from adding these two together, but the smallest number of decimal places is just this this one spot. So we're going to round to that tens place. And then in the subtraction, we get this big long number after the subtraction, but in this particular case, we have 4 decimal places, so we're going to round that number to 4 decimal places. Let's do a couple of examples. 12.4 plus 3.56. So 12.4 plus 3.56 equals 15.96. But the smallest or least amount of decimals is this 0.4. So I need to round this to the tens place. If I round it, though, this 9 goes up to 0, which makes this 16. So I'm actually writing 16, but I have to include the 0.0 because that's the 1 decimal here. So this is what we're looking for. Now, if we do the subtracting, 8.903 minus 2.11, 3 minus 2.11 equals, and we get 6.793. Okay, so in this case, we're looking at the decimal places. We got 2, so we have to round this to 2 decimal places, 6.7, and that 3 keeps this a 9, so 6.79. When we are doing multiplication or division, it's going to be different. We're not looking at the decimals, but we're looking at the least number of significant digits. So that's slightly different, and it has some examples here. If we multiply these two numbers, 2 in this case is the least number of significant digits, so they're going to round it to 2 significant digits. Okay, well, let's do an example. 3.24 times 2.1, 3.24 times 2.1 equals 6.804. But how many significant digits do we have? Well, this one number has 1, 2, 3. This number has 2. So we have to round this to 2 significant digits, which would be 6.8. Okay. Let's do the division here. 18. Now, 18.0, it's very important that you add that 0 because that 0 in this case is a significant figure. So that makes this top number, gives it 3 sig figs, and this bottom number 2 sig figs. So 18.0 divided by 4.2 equals 4.2857. I'll leave it there. Now we have to take the least number of sig figs. So this one has 3, this one has 2. So that means we're going to round this to 2, which gives me 4. Well, if I round using that 8, round this 2 up to 3, that will be my final answer. All right, see if you can get the rest of this done. If you have questions, let me know. Thanks.